Good morning. Okay, I'm going to do a quick recap of our lesson today about probability, our intro to probability lesson. These are your two types of probability that we're going to be talking about: experimental probability, and then we'll be talking about theoretical probability as well. So experimental probability is based on an experiment. So experimental is based on experiment. The results of an experiment. These are going to be things like problems that have a bar graph, problems that have the results of like a survey. These are based on the answers to an experiment. That is experimental probability. Theoretical probability is in theory or in a perfect world. In theory or in a perfect world. For example, if I were to roll a cube or roll a dice, there are 6 sides on a dice. One has the number 1, one side has 2, one side has the number 3, 4, 5, and 6. My chances of rolling a 6 would be 1 out of 6 because there's one side that says 6 out of 6 possible choices. So that's theoretical. It's not based on the results of an experiment. It's just in a perfect world. The example that we gave in class today was, what are the 4 options for dress that we have here at Montecasino? Well, we have uniform, we have free dress, we have mass dress, and we have spirit dress. Those are the 4 main categories of dress. So the probability of tomorrow being a free dress day would be 1 in 4, because that's one outcome out of 4 possible choices. However, tomorrow is a Tuesday. So based on my experience, I know that the probability of it being a mass dress day is much, much higher because it's a Tuesday. So that would be kind of the difference between theoretical and experimental. So for my first example here, it says, this bar graph shows the results of rolling a number cube 50 times. What's the experimental probability of rolling an odd? So to find out, now this tells me they rolled it 50, but on your homework it doesn't say that. So what you have to do is you have to take, how many times did they get a 1? 10 times. How many times did they get a 2? 4 times. How many times did they get a 3? 8 times. How many times did they get a 4? 11 times. How many times did they get a 5? 11 times. How many times did they get a 6? 6 times. Add those up. 10, 4, 8, 11, plus 11, plus 6, and that equals 50. So that tells me the number of trials or the number of times they rolled that cube. And the way I write probability equals the desired outcome. Sorry, it's hard to write and hold the phone at the same time. Desired outcome over number of possible outcomes. So the desired outcome, or number of desired outcomes, over the number of possible outcomes. So that means there's 50 possibilities, and it says, what is the probability of rolling an odd? Well, I know that odds are 1, 3, and 5. So I know that they got an odd here 10 times. They got this odd 8 times, so 10 plus 8 is 18. And they got this odd 11 times. And 18 plus 11 is 29. So I know that I would write that as The probability is 29 out of 50 because they rolled an odd 29 times out of 50 total times. That's how I would write that probability. Now to turn that into a percent, I would do what I do with fractions to turn them into decimals and then percents. I would do top divided by bottom. And that is 0.58 or 58%. On your homework, I believe it just asks you to leave it in fraction form. My next example says this was a survey. It says they surveyed 50 kids. If I didn't know that, I would do 15 plus 10 plus 13 plus 12 and find out that there were 50 answers given, so they surveyed 50 people. How many people said they liked language arts? 15. Math was 10. Science, 13. Social studies, 12. It says, what was the probability, or what is the probability of a student selecting math as their favorite subject? Well, the desired outcome of saying math happened 10 times out of 50 possible times. So that probability is 10 out of 50. This question goes on to ask, what would then be the probability if we surveyed the whole school? Based on this experiment, there are 1,240 kids in the school. So if 10 out of 50 said math, we set up a proportion to find out how many out of the whole school would likely say they like math. And I would have to multiply this by 24.8. I did 1240 divided by 50 and found out that I would have to multiply this by 24.8. So I would multiply the top by 24.8. 24.8 times 10 means there's 248 kids that if we did this experiment with everyone in the whole school, there should be about 248 kids that say they like math best. So that's what we use a proportion for there. All right, now, my last example said, this is rolling a number cube again. They really like rolling a number cube. And it says the bar graph shows the results of rolling a number cube 300 times. And if it didn't tell me, I would do 48 plus 53 plus 50 plus 52 plus 49 plus 48. And that would tell me that they rolled it 300 times. What is the experimental probability of rolling an odd? So I have to know that my odd numbers are 1, 3, and 5. They got a 1 48 times. They got a 3 50 times, so that's 98. And they got a 5 49 times. So 98 plus 49 is going to leave us with 147. So my probability of rolling an odd would be 147 because it happened 147 times in my experiment out of the total number of times I rolled, which was 300. And again, to find out a decimal or a percentage for this, top divided by bottom, that would give me 0.49, which would end up at 49%. So I hope that gives you a little more information about probability, experimental versus theoretical, how to write probabilities. They do not ask you to simplify on any of your probabilities today, so you can leave them just in your fraction form without simplifying. If you get stuck, let me know. I'm also going to post a couple of additional little videos on the topics board as well to help you.